The ground beneath southern Italy, a region steeped in ancient history and vibrant life, recently delivered a stark reminder of the immense power slumbering just below the surface. In May 2025, a significant seismic event, a magnitude 4.4 earthquake, rippled through the area surrounding Campi Flegrei. This was the most powerful earthquake to shake this volcanically active zone in 4 decades. For the people living there, it was a moment of sudden fear, a jolt that brought the abstract threat of the volcano into very real, tangible focus. Campi Flegrei, which translates from Italian to burning fields, is not your typical mountain-shaped volcano. Instead, it's a sprawling caldera, a vast depression in the Earth's crust formed by colossal eruptions thousands of years ago. The recent seismic activity isn't just a local geological curiosity, it's a signal from one of the planet's most dangerous volcanic systems, demanding our utmost attention and understanding. The May 2025 earthquake is a critical data point, a loud exclamation in an ongoing geological conversation. The notable magnitude 4.4 earthquake in May 2025 was not an isolated incident, but part of an intensifying symphony of seismic activity. Over 6 months, Campi Flegrei experienced over 3,000 tremors. Imagine a pot of water simmering before it boils. These micro-earthquakes are like that simmering, indicating a system becoming increasingly unstable. Scientists at INGV monitor this activity closely. They analyze the frequency, depth and location of these quakes to understand the processes unfolding deep underground. The sheer volume of these tremors suggests that pressure is building, and the rock formations are straining and fracturing. Another phenomenon observed at Campi Flegrei is bradyseism. Since 2005, the ground has been in a phase of uplift. In Pozzuoli, the ground has risen by approximately 4.7 feet. This uplift and the swarm of tremors indicate significant volcanic unrest. Beyond the shaking ground, another crucial indicator of Campi Flegrei's awakening is the rise in volcanic gas emissions, especially carbon dioxide or CO2. Italy's INGV reports daily CO2 emissions between 4,000 and 5,000 tons. This invisible exhalation is a direct message from the volcano's depths. Research led by Gianmarco Buono shows 80% of CO2 from Solfatara crater comes from deep magma. This suggests fresh magma is actively degassing, often linked to eruption likelihood. Increased CO2 and sulfur dioxide, with its rotten egg smell, are vital early warning signs. Monitoring these emissions is crucial for understanding potential eruptions. At the heart of Campi Flegrei's restlessness lies the presence of magma, molten rock, situated just a few miles below the Earth's surface. This relatively shallow depth is a key factor contributing to the current concerns. Imagine a massive underground reservoir of superheated, pressurized liquid rock. As this magma body stirs, releases gases, or is itself pushed upwards by deeper geological forces, it exerts immense pressure on the overlying crust. This pressure is the primary driver behind many of the observed phenomena, including the ground uplift, or bradyseism, and the increased frequency of earthquakes, as the rocks strain and break. Magma contains dissolved gases, much like a bottle of soda contains dissolved carbon dioxide. As magma rises closer to the surface, or as the pressure confining it decreases, these gases begin to come out of solution, forming bubbles. This process, known as exsolution, dramatically increases the volume of the magmatic mixture and consequently, the pressure it exerts. If this pressure exceeds the strength of the surrounding rock, the rock will fracture, potentially creating pathways for the magma to ascend further, leading to an eruption. Section 5. Echoes from the Past, Campi Flegrei's Fiery History. Campi Flegrei is not a newcomer to volcanic drama. Its past is written in layers of ash and rock, a testament to its long and often violent history. The most recent eruption, though relatively small by supervolcano standards, occurred in 1538. This event created a new cinder cone, Monte Nuovo, and while disruptive locally, it pales in comparison to the caldera's more ancient and formidable outbursts. The most infamous event in Campi Flegrei's geological record is the Campanian ignimbrite eruption, which occurred approximately 40,000 years ago. This was a cataclysmic event, one of the largest volcanic disasters in Earth's history. The eruption was so colossal that it ejected hundreds of cubic kilometers of ash and rock, blanketing vast swaths of Europe and significantly altering the global climate for years, potentially contributing to the decline of Neanderthal populations. It was this eruption that largely formed the caldera as we see it today, a stark reminder of the supervolcano's destructive capabilities when it truly awakens. Section 6. Living on the edge, the human presence near the giant. The geological drama unfolding at Campiflegrei is not happening in a remote, uninhabited wilderness. Instead, this awakening supervolcano lies in disturbingly close proximity to a densely populated urban area. The metropolitan area of Naples, a vibrant and historic region, is home to over 4 million people. Many towns and communities, such as Pozzuoli, are situated directly within or on the very edge of the caldera itself. This means that a significant population lives, quite literally, on top of one of the world's most hazardous volcanic systems, creating a scenario of immense potential risk. Should Campiflegrei proceed towards a significant eruption, the immediate local impacts would be catastrophic. The proximity of towns like Pozzuoli to the active vents within the caldera, such as Solfatara, places them in an extremely vulnerable position. The challenge therefore is not just a scientific one of understanding the volcano, but a profound societal one of managing the risk to such a large population. Section 7. Bracing for impact preparedness in the face of uncertainty. Given the significant threat posed by Campiflegrei, Italian authorities and scientific institutions are not standing idly by. Recognizing the escalating signs of unrest that began to emerge more clearly around 2005, the volcano's alert level was officially raised from green, quiet, to yellow, attention monitoring, in 2012. This change signaled an increased state of vigilance and triggered more intensive monitoring and preparedness activities. Comprehensive evacuation plans have been developed for the millions of people residing in the Naples metropolitan area and the towns within the red zone, the area deemed most at risk in the event of an eruption. Scientific monitoring is the bedrock of this preparedness. Institutions like Italy's National Institute of Geophysics and Volcanology, INGV, operate a sophisticated network of sensors around Campiflegrei. Despite these extensive preparations and advanced monitoring systems, the inherent uncertainty in predicting volcanic eruptions remains a significant hurdle. Section 8. Global ripples, the far-reaching consequences of an eruption. The potential impact of a major eruption at Campiflegrei would not be confined to the immediate vicinity of Naples. While the local devastation would undoubtedly be the most acute, a large-scale explosive event, similar to the one that occurred 40,000 years ago, would have profound and far-reaching consequences, sending ripples across Europe and potentially affecting the entire globe. The sheer volume of material ejected into the atmosphere during such an eruption could trigger a cascade of environmental and societal disruptions on an international scale, reminding us of Earth's interconnected systems. One of the most significant global impacts would be the dispersal of volcanic ash. A massive ash plume, driven by prevailing winds, could blanket much of Europe. This would lead to widespread grounding of air travel, as volcanic ash is highly abrasive and can cause jet engines to fail, leading to enormous economic disruption. Beyond the immediate effects of ash, the injection of volcanic gases, particularly sulfur dioxide, into the stratosphere would have a significant impact on global climate. A major eruption at Campiflegrei could release enough sulfur dioxide to cause a noticeable drop in global average temperatures for several years. Section 9. The unpredictable giant vigilance in the shadow of the volcano. Despite the advances in volcanology and our ability to monitor the subtle stirrings of giants like Campiflegrei, a fundamental truth remains. Predicting exactly when or even if a major eruption will occur is an incredibly complex challenge. Scientists can identify periods of heightened unrest, like the one currently being observed, characterized by increased seismicity, ground deformation, and gas emissions. These signs strongly suggest that the volcanic system is stressed, and that the likelihood of an eruption is higher than during quiescent periods. However, volcanoes are notoriously fickle. Periods of unrest can sometimes wane without culminating in an eruption. The current scientific consensus is that while an eruption is not necessarily imminent, the observed trends warrant extreme vigilance and continued, intensified monitoring of every parameter. Living in the shadow of a supervolcano like Campi Flegrei requires a delicate balance of respect for nature's immense power and a commitment to